Welcome to Sleepy Discoveries. Tonight we begin a gentle journey into one of Earth's most remarkable natural wonders, the Grand Canyon. This vast landscape reveals the quiet strength of natural forces and the astonishing influence of time stretched across unimaginable ages. To gaze into the canyon is to sense the true scale of our planet, a reminder that Earth is never still, always shaping and reshaping itself. Our exploration will not remain in Arizona alone. From here, our thoughts drift outward to other immense canyons across the globe, carved through deserts, hidden within rainforests, rising among Himalayan heights, and descending toward ocean depths. Beyond Earth, we will even imagine distant worlds, where planetary forces sculpt chasms as dramatic as those beneath our feet. If you enjoy these peaceful journeys, you're warmly invited to like, subscribe, or share a quiet thought in the comments below. Each small gesture helps another sleepy soul find their way here. For now, simply relax. Let your breathing slow, your thoughts soften, and allow yourself to sink into this timeless voyage. The Grand Canyon unveils nearly 2 billion years of Earth's history, laid bare like the pages of an ancient book. Unlike most landscapes where soil and vegetation hide the past, the canyon exposes it openly in layered bands of color. Younger formations rest above, while deeper walls reveal rocks formed when our planet was still young. Standing at the rim means witnessing not only distance, but time itself, stacked stone upon stone. Scientists have studied these layers as records of vanished climates, long-lost ecosystems, and geological events that occurred long before human existence. At the canyon's base lie some of the oldest exposed rocks on Earth, known as the Vishnu Basement Rocks. These metamorphic stones and ancient granite intrusions date back roughly 2 billion years, nearly half the age of the planet itself. Within them are traces of vanished mountain ranges, compressed ocean crust, and immense tectonic collisions that once shaped the continents. To touch these rocks is to connect with matter that has endured heat, pressure, folding, and uplift across deep time. Very few places on Earth reveal such ancient material at the surface, making the Grand Canyon one of the clearest windows into the planet's earliest foundations. The canyon itself, however, is far younger than the rocks it exposes. The Colorado River, winding through its depths today, began carving this immense chasm millions of years ago. While scientists still debate the exact timeline, most agree the river began cutting into the rising Colorado Plateau at least 5 to 6 million years ago. Gravity guided the water through fractures and softer layers, while tributaries joined in, slowly deepening and widening the gorge. What makes this story extraordinary is its patience. Every curve and cliff stands as evidence of water's quiet persistence. The canyon is not a frozen relic, but a living feature, still changing, still responding to uplift, erosion, and time. Though its stones speak of ancient worlds, the canyon itself remains geologically young, a fresh opening in Earth's crust, revealing its deepest memories. Erosion continues to shape the canyon's grandeur. Alongside flowing water, wind, ice, and gravity work together. Rain and snow seep into cracks, freezing and expanding stone. Rock falls thunder downward, feeding the river below. Fine dust carried by wind gently scours exposed surfaces. Over millions of years, these forces have sculpted a maze of cliffs, ridges, and side canyons, an ongoing natural experiment in slow transformation. Deep within the canyon, the Vishnu schist glimmers with minerals such as mica, and garnet. Formed under extreme heat and pressure, these dark crystalline rocks sparkle when touched by light, revealing tiny crystals born deep within Earth's interior. Geologists treasure them as records of a time when life was microscopic and continents were still taking shape. Their dark sheen contrasts sharply with the pale layers above, telling a story preserved in stone for billions of years. The Grand Canyon is more than a monument of rock. It is a quiet archive of vanished seas, ancient deserts, and long-forgotten rivers, a reminder that beneath our feet lies a history far older, deeper, and more enduring than we can easily imagine. Fossils embedded within the canyon walls reveal environments that shifted dramatically over hundreds of millions of years. In certain layers, marine remains show that the region was once submerged beneath shallow seas, teeming with brachiopods, corals, and trilobites. Elsewhere, preserved footprints and plant impressions point to ancient riverbanks and floodplains. There are even sandstones that retain the rippled patterns of long-vanished desert dunes. Each fossil serves as a quiet clue, hinting at former worlds where oceans advanced and retreated, rivers altered their paths, deserts expanded, and forests took root. Together, these traces form a timeline of Earth's changing surface, illustrating how ecosystems emerged, transformed, and disappeared. For paleontologists, the Grand Canyon is not only a monument of stone and water, but a living archive of landscapes and life that once flourished where cliffs and valleys now stand. Although the Grand Canyon is best known for its layered, sedimentary rocks, it also bears marks of fire. In its western reaches, hardened basalt fields reveal places where volcanic eruptions once poured molten rock across the land. Some of these lava flows, dating back only a few 100,000 years, spilled into the canyon itself, temporarily blocking the Colorado River. Behind these natural dams, vast lakes formed until the river eventually broke through and resumed its course. Evidence of these dramatic events can still be seen in basalt cliffs and scattered volcanic cones rising above the canyon rim. For geologists, these lava remnants tell an important story. The canyon is not shaped by erosion alone, but also by the restless heat of Earth's interior. It is a dynamic landscape, molded by multiple powerful forces rather than a single, unchanging process. One of the canyon's most mesmerizing features is its shifting display of color. At sunrise and sunset, when sunlight strikes the walls at low angles, the layers glow in vivid shades of red, orange, gold, and violet. These hues arise from the minerals locked within the rocks themselves. Iron oxides produce warm reds and yellows, limestone reflects softer cream tones, and darker layers absorb light, deepening shadows and contrast. The canyon's immense scale amplifies this effect as ridges and cliffs catch the light differently, creating a living mosaic that changes from minute to minute. Atmospheric conditions, humidity, dust, and even distant wildfire smoke can further transform the palette, sometimes lending the canyon an almost otherworldly appearance. For visitors, this spectacle is breathtaking, a reminder that geology is not only ancient, but vividly alive in light, color, and motion. Beyond its beauty, the canyon's rock layers preserve clear evidence of ancient climate change. Sandstones record eras when winds sculpted towering dunes across arid deserts. Limestone layers speak of times when warm, shallow seas covered the region, leaving behind shells and coral fragments. Shales reveal muddy floodplains and slow-moving rivers. By studying these rocks, scientists reconstruct long-term climate shifts, from tropical coastlines to dry continental interiors. These transformations reflect the movement of continents, rising and falling sea levels, and repeated ecological upheavals. The canyon is therefore more than a dramatic landscape. It is a vast environmental archive, offering deep time lessons about how climates evolve and reshape the world we inhabit today. Stretching across northern Arizona, the Grand Canyon is not merely a single chasm, but an immense geological corridor extending for roughly 277 miles. It slices through the Colorado Plateau like a scar carved by time, making it one of the largest continuous geological features on Earth. What makes this distance remarkable is its variation. Along its course, the canyon's depth, width, and rock character constantly change, revealing a shifting panorama of cliffs, mesas, meadows, and branching side canyons. From the arid eastern reaches to the remote western regions near Lake Mead, each bend introduces a new expression of the landscape. This great length also spans multiple climate zones, where desert environments gradually give way to forested highlands. To traverse the canyon's full extent is to cross a living cross-section of the American Southwest. While its depth is legendary, the canyon's width is equally astonishing. In some places, the distance from rim to rim exceeds 10 miles, so vast that details on the far side dissolve into the horizon. This width varies dramatically, narrowing sharply in certain sections while expanding elsewhere, as erosion eats outward into softer rock layers. Scientists attribute these differences to variations in rock strength and erosion rates, where weaker formations allow the canyon to spread wider over time. Standing at the edge, the sheer breadth emphasizes the immense forces involved. This is not simply a river valley, but a colossal landscape widened by water, gravity, and deep time working together. In certain regions, the canyon plunges to depths greater than a mile. This vertical scale is what leaves such a lasting impression. At its deepest points, the canyon floor lies more than a mile below the rim, creating one of the steepest descents found anywhere on Earth. The drop is not smooth, but formed by countless cliffs, terraces, and slopes stepping downward through the rock layers. For hikers, this depth brings dramatic changes in temperature, vegetation, and air density with every descent, a powerful reminder that the canyon is not just wide and long, but profoundly deep. Fossils preserved within the canyon walls reveal a sequence of environments that transformed dramatically over hundreds of millions of years. In some layers, marine remains indicate that shallow seas once covered the region, filled with brachiopods, corals, and trilobites. In other strata, fossilized footprints and plant impressions point to ancient riverbanks and broad floodplains. There are even desert sandstones that still carry the rippled patterns of dunes shaped by winds long gone. Each fossil offers a fragment of an earlier world, recording shifting shorelines, wandering rivers, expanding deserts, and forests that slowly took hold. Together, these traces form a deep timeline of Earth's surface, showing how ecosystems emerged, adapted, and ultimately vanished. For paleontologists, the Grand Canyon is not merely stone carved by water, but a living archive of once thriving landscapes and life forms that existed where cliffs now rise. Although the Grand Canyon is famous for its layered, sedimentary rocks, it also holds evidence of volcanic fire. In the western sections, hardened basalt fields mark places where eruptions once spilled molten rock across the land. Some of these lava flows, dating back only a few 100,000 years, poured into the canyon itself, temporarily damming the Colorado River. Vast lakes formed behind these natural barriers until the river eventually broke through and reclaimed its path. Traces of these events remain visible today in towering basalt cliffs and scattered volcanic cones along the canyon rim. To geologists, these lava flows demonstrate that the canyon is far more than a product of erosion alone. It tells a story shaped not only by water and stone, but also by the fiery forces rising from deep within Earth, reminding us that this landscape is dynamic rather than fixed. One of the canyon's most captivating qualities is its shifting display of color. At sunrise and sunset, when sunlight strikes the walls at a low angle, the rock layers ignite with vivid shades of crimson, amber, gold, and violet. These colors arise from the minerals embedded in the stone. Iron oxides produce reds and yellows, limestone reflects soft cream tones, and darker layers absorb light, intensifying shadows and contrast. The canyon's immense scale enhances this effect as ridges and cliffs catch the light differently, forming a moving mosaic that changes from moment to moment. Scientists note that atmospheric conditions, humidity, airborne dust, and even smoke from distant wildfires can further alter the palette, sometimes giving the canyon an almost surreal appearance. For visitors, this spectacle is unforgettable, revealing that geology is not only ancient, but vibrantly alive through light, form, and color. Beyond its visual beauty, the canyon's rock layers preserve clear evidence of long-term climate change. Sandstones record eras when powerful winds sculpted desert dunes. Limestone layers mark periods when warm, shallow seas flooded the region, leaving behind shells and coral remains. Shales reveal muddy floodplains and slow-moving rivers. By studying these formations, scientists reconstruct shifting climates that ranged from tropical coastlines to dry continental interiors. These changes reflect drifting continents, fluctuating sea levels, and repeated transformations of ecosystems over immense spans of time. As a result, the canyon is more than a dramatic landform. It is a vast environmental record showing that change is constant and often profound. For researchers, it offers valuable insight into how climates evolve and how those patterns continue to shape the world today. Stretching across northern Arizona, the Grand Canyon is not simply a deep valley, but an immense geological corridor extending roughly 277 miles. It cuts across the Colorado Plateau like a scar etched by time, making it one of the largest continuous geological features on the planet. What makes this length remarkable is its diversity. Along its course, the canyon's depth, width, and rock character shift continuously, creating a varied panorama of cliffs, mesas, meadows, and branching side canyons. From the arid eastern deserts to the remote western reaches near Lake Mead, each turn reveals a new expression of the landscape. This great span also crosses multiple climate zones, where dry desert conditions gradually transition into forested highlands. To experience the canyon in its entirety is to pass through a cross-section of the American Southwest itself. While its depth is legendary, the canyon's width is equally astonishing. In certain areas, the distance from rim to rim exceeds 10 miles, so vast that details on the opposite side fade into the horizon. This width is not uniform. In some places, the canyon narrows dramatically, while in others it expands as side valleys and eroded cliffs push the boundaries outward. Scientists attribute these variations to differences in rock composition and erosion rates, as softer layers wear away more easily, allowing the canyon to broaden over time. Standing at the rim, the immense width emphasizes the scale of the forces involved. This is not simply a river valley, but a colossal landscape shaped by water, gravity, and deep time working together. In certain sections, the canyon descends to depths greater than a mile. This vertical scale is what makes the Grand Canyon so unforgettable. At its deepest points, the canyon floor lies more than a mile below the rim, forming one of the steepest natural descents on Earth. The drop is not smooth, but broken into countless cliffs, terraces, and slopes, stepping downward through the rock layers. For hikers, this depth brings dramatic changes in temperature, vegetation, and air density with every descent. Scientists study this vertical relief as a record of erosion, shaped by the Colorado River cutting downward while the Colorado Plateau simultaneously arose upward. The result is a chasm so vast it challenges human perception. From the rim, the river below may appear impossibly small, yet it has been the driving force behind this immense excavation for millions of years. On clear days, views from the canyon rim extend astonishingly far. When the air is free of dust and haze, visitors can see well over 90 miles across the plateau. This sweeping visibility is possible because of the region's high elevation, which offers an expansive vantage point across the surrounding landscape. During colder months especially, the clarity of the air allows sunlight to reveal distant ridges, cliffs, and mountain ranges that seem to stretch endlessly toward the horizon, giving the impression that the land itself fades into time. Scientists explain that the region's dry desert climate often helps preserve exceptional visibility, though wildfires, pollution, and seasonal storms can occasionally obscure it. For those who experience these vast views, the sensation can feel almost otherworldly, a panorama so expansive that it stretches beyond normal depth perception. This ability to see across such immense distances is a key reason the Grand Canyon is considered one of the most awe-inspiring landscapes on Earth. The canyon is so immense that it generates its own weather patterns. Its towering walls and immense depth create strong temperature gradients that influence wind behavior, cloud formation, and precipitation. During summer, heat trapped within the canyon can drive rising air currents, triggering sudden thunderstorms that build directly above cliffs and valleys. In winter, cold air often settles along the river, producing temperature inversions where the canyon floor lies beneath a blanket of mist, while the rim remains sunlit. These microclimates are more than curiosities. They shape ecosystems, determine where plants can survive, guide animal movement, and influence how water flows. Scientists study these effects as powerful examples of how terrain can control climate on a local scale. For visitors, this means that conditions at the rim and along the river can feel like entirely different worlds, changing rapidly before their eyes as wind, clouds, and light shift. One of the canyon's most striking experiences is the extreme temperature contrast between the rim and the river below. On summer days, the rim may feel pleasantly warm, while the inner canyon along the Colorado River can be more than 30 degrees hotter, reaching dangerously intense heat. This contrast results from an elevation difference of more than a mile, which affects air density and heat retention. Cooler air lingers above, while the deeper canyon traps warmth, especially where sunlight reflects off dark rock surfaces. For hikers, this can be hazardous, as a descent that begins in mild conditions may quickly turn into a battle against extreme heat. At the same time, this temperature gradient supports a remarkable range of ecosystems, where high elevation forests gradually give way to desert vegetation near the river. This diversity makes the Grand Canyon a natural laboratory for studying microclimates. The canyon's vast scale also creates an unusual relationship with light. In the morning, as the sun rises above the rim, shadows cast by cliffs can stretch for miles across the canyon floor. In some areas, these shadows linger for hours, leaving sections of the canyon in darkness long after sunrise. In the evening, the process reverses, with massive shadows slowly descending into the depths. Scientists note that this prolonged shading affects temperatures, evaporation rates, and even plant growth in certain locations. It also enhances the canyon's dramatic appearance, as the layers of light and shadow continually reveal new details. For attentive observers, watching shadows drift slowly down the walls becomes a powerful reminder of the canyon's immense vertical scale, measured not only in stone but in the movement of light itself. Sound behaves in unexpected ways within the Grand Canyon. Voices, footsteps, or clapping can travel great distances, bouncing off rock walls and returning in strange, fragmented echoes. In some locations, sounds repeat multiple times, as if the canyon itself were responding. In others, noise seems to vanish entirely, absorbed by irregular surfaces and lost in the vast open space. Researchers who study acoustics note that the canyon's size and complex geometry create unusual effects, making it a natural laboratory for the physics of sound. For wildlife, these acoustic conditions can aid or hinder survival, as both predators and prey rely on sound to communicate. Visitors often describe the experience as unsettling, since the canyon does not respond to sound in familiar ways, where the faintest noise may echo loudly, while the strongest call can dissolve into silence. From certain viewpoints along the rim, the landscape feels almost alien. Because of its immense scale, intense colors, and profound depth, the Grand Canyon is frequently compared to extraterrestrial terrain. In some locations, the view stretches so far and wide that it overwhelms ordinary perception, creating the impression of standing on another planet. The palette of red rock, pale stone, and violet shadows closely resembles images sent back by spacecraft exploring Mars. Scientists have even drawn comparisons between erosion features in the canyon and those observed in Martian valleys and cliffs. For visitors, the effect is deeply emotional. The sheer immensity disrupts the mind's ability to measure space intuitively, producing a sense of awe mixed with disorientation. In this way, the Grand Canyon does more than tell the story of Earth's past. It challenges our perception of space itself, reminding us that landscapes can feel unfamiliar, even on our own world. Viewing the canyon from above reveals patterns hidden from the ground. From the rim, the Grand Canyon already appears immense. But from the air, an entirely new perspective emerges. Seen from an airplane or helicopter, the canyon resembles a vast branching network, with the Colorado River as its main artery and countless side canyons spreading outward like veins across the plateau. These patterns are nearly impossible to grasp from below, where cliffs block the view of neighboring valleys. Scientists rely on aerial surveys and satellite imagery to map erosion features, locate hidden caves, and identify ancient landslides. From this vantage point, researchers gain critical insight into how the canyon formed and how it continues to evolve. For those fortunate enough to fly over it, the experience is breathtaking. The canyon's overwhelming scale becomes suddenly legible, as if nature's blueprint were drawn directly onto the land. Long before it became a national park or a symbol of natural wonder, the Grand Canyon was home to indigenous peoples who lived along its cliffs and river valleys for thousands of years. Archaeological evidence shows human presence in the region for more than 12,000 years. These early inhabitants adapted to the canyon's diverse environments, moving with the seasons and making careful use of its resources. Remnants of tools, dwellings, and food sources tell a story of resilience and innovation in a land of both hardship and abundance. The canyon provided shelter, fertile patches for cultivation, and for many indigenous nations, profound spiritual meaning that continues to this day. To truly understand the Grand Canyon is to look beyond its layers of stone and erosion and recognize the human story woven through it. For thousands of years, people have lived with this landscape, shaping their lives around its depths and rhythms. The canyon is not only a record of geological time, but also a place where human history and the present remain closely connected. For the Hopi people, the Grand Canyon is far more than a dramatic landform. In Hopi tradition, it is a sacred place tied to their origins and their emergence into this world. Certain locations within the canyon hold deep spiritual importance, honored through stories, ceremonies, and ancestral memory. This perspective reveals the canyon as a living presence rather than a silent backdrop. While scientists study its rocks to understand time, the Hopi see the canyon as a continuing story, rich with meaning beyond its physical form. Deep within the canyon, the Havasupai people continue to live where few others have remained. Unlike many indigenous groups who reside on the surrounding plateaus, the Havasupai have maintained their villages in the canyon's interior. Their homes lie near hidden waterfalls and fertile ground nourished by clear streams flowing toward the Colorado River. Their name, meaning people of the blue-green waters, reflects a lasting connection to the striking turquoise pools of their homeland. For centuries they have farmed, built homes, and adapted their lives to the canyon's demanding environment. Today, they preserve their traditions while welcoming visitors who reach their valley on foot or horseback, embodying a rare continuity between ancient presence and modern life. Traces of even older cultures remain etched into the canyon's walls. Along its cliffs, remnants of ancestral puebloan dwellings still cling to sheltered rock faces. Built from stone and earth nearly 1,000 years ago, these homes demonstrate a deep understanding of the canyon's challenges. Elevated positions offered protection from floods and enemies, while maintaining access to water and farmland below. Preserved by the dry desert climate, these structures serve as quiet windows into daily life long ago, reminding modern observers that the canyon has long been a lived-in landscape. The canyon also bears human marks carved directly into stone. Petroglyphs, images etched into rock surfaces, appear throughout the Grand Canyon and its side canyons. Many of these designs, depicting animals, human figures, and symbolic forms, are thousands of years old. Archaeologists interpret them as expressions of ritual, communication, and cultural memory, though much of their meaning remains unknown. For indigenous communities, these carvings maintain spiritual significance, linking present generations to their ancestors. Unlike painted images that fade, petroglyphs endure, making them some of the most lasting human records within the canyon. The first Europeans to record the Grand Canyon encountered it in the 16th century when Spanish explorers searching for legendary cities of gold arrived at its edge. Instead of wealth, they found an immense chasm that defied expectation. Attempts to descend revealed distances and dangers far greater than anticipated. Their written accounts describe both awe and frustration, capturing the difficulty of comprehending such a vast landscape. Though this marked the canyon's entrance into European records, it had already been home to people for millennia. In the 19th century, American explorers faced similar challenges. As settlers moved westward, the Grand Canyon stood as a formidable barrier rather than a simple landmark. Steep cliffs and impassable terrain forced long detours, and many expeditions failed to cross it. These early encounters reinforced the canyon's reputation as a symbol of the untamed American West, powerful, imposing, and resistant to human passage. One of the most influential figures in the canyon's exploration was John Wesley Powell. A Civil War veteran who had lost an arm, Powell led a daring expedition in 1869 down the uncharted Colorado River. Traveling in wooden boats through violent rapids and narrow gorges, his team faced constant danger. Boats were lost, supplies dwindled, and some men abandoned the journey. Powell pressed on, documenting the canyon's geology and geography in unprecedented detail. His work transformed the Grand Canyon from an unknown obstacle into a subject of scientific understanding and public fascination. By the late 19th and early 20th centuries, railroads brought easier access to the canyon. What had once required extreme effort to reach became visible to a wider world. As more people arrived, the Grand Canyon shifted in public perception, from a place defined by danger and isolation to one recognized for its grandeur, cultural depth, and enduring human presence. Before the arrival of modern transportation, reaching the rim of the Grand Canyon required endurance and determination. The journey was long, difficult, and usually undertaken only by explorers, local communities, or the most persistent travelers. That changed dramatically with the expansion of the Santa Fe Railway. For the first time, visitors could reach the South Rim with relative ease. This single development transformed the canyon into a national destination, drawing scientists, artists, and curious travelers eager to witness its scale firsthand. Hotels, viewpoints, and visitor facilities soon followed, laying the groundwork for modern tourism. The railroad did more than shorten travel time. It reshaped how the canyon was perceived, shifting it from a distant wilderness into a celebrated natural wonder accessible to the public. This moment marked the beginning of the canyon's dual identity as both a scientific landmark and a cultural icon. In the early 20th century, the Grand Canyon received formal protection. In 1919, it was designated a United States National Park, securing its status as one of the world's most protected and revered landscapes. This decision followed years of advocacy by conservationists and public figures. President Theodore Roosevelt famously argued that the canyon should be preserved exactly as it was, untouched for future generations. National park status ensured that its geology, ecosystems, and culturally significant sites would be shielded from unchecked development. Since then, millions of visitors from around the globe have come to experience it, making the park one of the most visited natural areas on Earth. The designation reflects not only its scientific importance, but also its role as a shared natural legacy meant to inspire wonder long into the future. High above the canyon walls, California condors glide on rising currents of warm air. With wingspans approaching 3 meters, these massive birds are the largest flying land birds in North America. Once pushed to the brink of extinction, their population fell to fewer than 30 individuals by the late 20th century. Through intensive conservation efforts involving captive breeding and reintroduction, their numbers slowly recovered. Today, the Grand Canyon remains one of the few places where visitors can witness these ancient birds soaring freely once again. Seeing a condor circle above the cliffs is a reminder that conservation is not just about protecting landscapes, but also about restoring the lives that depend on them. On the canyon's steep slopes, desert bighorn sheep move with astonishing confidence. Few animals are as perfectly adapted to this vertical terrain. Their specially shaped hooves grip rock surfaces with remarkable stability, allowing them to navigate ledges where a single misstep could be fatal. These heights offer protection from predators, providing refuge in places few others can reach. For centuries, indigenous peoples observed and hunted these animals, recognizing their strength and resilience. Today, bighorn sheep remain an important indicator species. Their ability to survive reflects the health of the canyon's water sources and vegetation. Watching them ascend near vertical cliffs offers a vivid example of evolution refining life for even the most extreme environments. As night falls, a very different creature emerges. The ringtail, despite its name, is not a cat, but a small nocturnal relative of the raccoon. Rarely seen by visitors, ringtails roam the canyon after dark, climbing walls and slipping across rocky ledges in search of insects, rodents, and fruit. Their large eyes and striped tails are perfectly suited for life in low light. Historically, some indigenous communities even encouraged ringtails near storage areas because they helped control pests. Today, they remain quiet but essential members of the ecosystem, regulating smaller animal populations. Catching a glimpse of one moving silently through the rocks under starlight is an uncommon and memorable experience. Among the canyon's most unexpected inhabitants are tiny freshwater snails, found nowhere else on Earth. These fragile species live in isolated springs and seeps that emerge from the canyon walls, clinging to aquatic plants or the undersides of stones. Each spring functions as a miniature ecosystem, allowing species to evolve independently over thousands of years. Because their survival depends entirely on the stability of the hidden water sources, they are especially vulnerable to climate change and groundwater disruption. Scientists study them closely as their presence or absence reveals much about environmental health. Though easy to overlook, these small creatures represent some of the canyon's most delicate and ancient survival stories. Despite often being imagined as a single desert landscape, the Grand Canyon contains an extraordinary range of ecosystems. Along the rim, cooler temperatures support forests of ponderosa pine, aspen, and spruce. Descend just a mile, and the environment transforms into a hot inner canyon dominated by cacti, creosote bushes, and desert plants. This dramatic change in elevation mirrors the climatic shift one would experience traveling from Canada to Mexico. Such vertical diversity allows an exceptional variety of plants and animals to coexist within a relatively compact area. For scientists, the canyon serves as a natural laboratory for studying how altitude and microclimates shape life. For visitors, hiking from rim to river feels like passing through entirely different worlds, stacked one above the other, each with its own rhythms, species, and character. The dramatic drop in elevation within the Grand Canyon creates striking contrasts in plant life. Along the rim, cooler temperatures and higher levels of precipitation support forests of pine, juniper, and oak, landscapes more reminiscent of northern woodlands than desert terrain. As one descends toward the river, this greenery gradually gives way to arid vegetation, spiny cacti, hardy desert shrubs, and willows clustered along watercourses. Between these extremes lie transitional zones where grasses, shrubs, and seasonal wildflowers emerge after rainfall. Each 1,000 feet of elevation marks a noticeable shift in climate, stacking distinct habitats one above another. Together, they form one of the most diverse botanical mosaics in North America. Scientists studied the canyon as a natural experiment in plant adaptation, while hikers experience the descent as a journey through multiple ecosystems compressed into a single landscape. Beyond the main chasm, hundreds of narrow side canyons branch outward, each functioning as a world of its own. Many contain shaded alcoves, seep springs, and sheltered pockets where rare or absent species elsewhere manage to survive. Isolation has allowed plants and animals to evolve in small, specialized populations, turning these side canyons into biodiversity hotspots. Some harbor relict species that once ranged widely but now persist only in protected niches. Others support amphibians, insects, or fish whose entire populations are confined to a single canyon arm. For researchers, these hidden corridors offer insight into how isolation shapes evolution and resilience. For explorers, they are secret landscapes where life clings tightly to water and shadow within an otherwise vast desert. Although the canyon's depths are hot and dry, the higher elevations along its rim support expansive forests that sustain large mammals such as elk and mule deer. These animals graze on grasses, shrubs, and young tree shoots, often appearing at dawn or dusk near meadows and water sources. Mule deer, easily recognized by their large ears, are especially common along the south rim, while larger elk favor the cooler northern forests. Both species play vital ecological roles, influencing plant communities and serving as prey for predators like mountain lions. Their presence links the canyon to the broader ecosystems of the Colorado Plateau. For visitors, spotting a deer stepping quietly from the trees brings the canyon's vast scenery into balance with the rhythms of wildlife that move through it. Reptiles are among the canyon's most visible and well-adapted residents. Lizards dart across rocks and trails, their quick movements and vivid colors catching the eye. Species such as the collared lizard display flashes of turquoise, green, and yellow, especially during territorial displays. Others, including whiptail and side-blotched lizards, rely on speed and camouflage to evade predators. Their cold-blooded physiology allows them to absorb heat from sun-warmed stone, while their small size and agility let them slip into crevices to escape danger or regulate temperature. Lizards occupy a crucial place in the food web, feeding on insects and providing prey for birds, snakes, and mammals. Watching one bask motionless on a glowing red rock offers a miniature reflection of the canyon's resilience and beauty. Hidden within shaded caves and spring-fed pools, tiny frogs add an unexpected note of life to the canyon. These moist refuges remain cool and damp year-round, forming oases for amphibians in an otherwise arid environment. One notable resident is the canyon tree frog, which clings to rocks near waterfalls and streams. On warm summer nights, its sharp, echoing calls bounce off stone walls, an unlikely sound amid the desert silence. Because amphibians are highly sensitive to water quality and temperature, their presence signals the health of these fragile aquatic habitats. Encountering one can feel magical, a sudden reminder that even the driest landscapes shelter delicate forms of life. At the heart of the Grand Canyon flows the Colorado River, the relentless force responsible for carving much of the chasm seen today. Originating in the Rocky Mountains and traveling more than 1,000 miles toward the Gulf of California, the river cuts through the canyon in a corridor roughly 300 miles long. Along this path, it presses against sheer walls, slicing through ancient rock layers and continuing to deepen and shape the land. Its power comes not only from water, but from the sediment it carries, sand, gravel, and stone that grind away at the canyon with every flood. For indigenous peoples, the river has long been a source of sustenance and spiritual meaning. For scientists, it remains a living example of slow, yet unstoppable erosion. Standing beside it feels like witnessing the canyon's beating heart. The Colorado River is also famous for its whitewater rapids, some of the most intense in North America. Rapids such as Lava Falls, Crystal, and Horn Creek are legendary among rafters, with towering waves and steep drops that challenge even the most experienced adventurers. These turbulent stretches form where landslides, rockfalls, or resistant rock layers narrow the channel, forcing water into violent motion and creating stand-in waves that can rise higher than a person. Rapids in the Grand Canyon are ranked on a unique scale from 1 to 10, with the most powerful earning the highest ratings. For scientists, they reveal how rivers interact with geology in real time, constantly reshaping themselves after floods and collapses. For those who dare to run them, the experience is unforgettable. A direct encounter with raw natural force set against one of the world's most extraordinary landscapes. Some rafting journeys last for weeks, unfolding as long, immersive passages through stone, water, and time. Rafting through the Grand Canyon is not a brief adventure, but a commitment measured in weeks rather than hours. Complete river journeys that follow the Colorado River from start to finish often last more than 2 weeks. Along the way, rafters navigate dozens of powerful rapids, set up camp on shifting sandbars, and explore hidden side canyons accessible only from the water. The experience is physically demanding and deeply immersive. With no roads or quick exits, the river becomes a self-contained world, far removed from modern noise and distraction. Scientists also undertake extended river expeditions, using the journey to study geology, hydrology, and ecosystems from within the canyon itself. These long passages reveal insights impossible to gain from overlooks or short visits. For many travelers, the length of the journey is transformative, forcing a gradual alignment with the rhythms of the river and the canyon walls. It is a reminder that some landscapes can only be understood through patience, endurance, and time. The Colorado River has not always followed its present course. What we see today is only the latest chapter in a long history of shifting paths. Over millions of years, tectonic uplift, landslides, and volcanic activity repeatedly redirected the river. Evidence of abandoned channels, filled with sediment and fossils, can still be found across the canyon and surrounding plateau. At times, lava flows or massive rock falls temporarily dam the river, creating vast lakes that eventually drained or burst through their barriers. In other periods, rising land forced the river to carve deeper roots, leaving older valleys behind. For geologists, these ancient channels are essential clues for reconstructing the canyon's past. For visitors, they serve as a humbling reminder that the Grand Canyon is not a fixed monument, but a landscape still evolving. The river continues to change, and its future path may look very different from what we know today. Human engineering has also reshaped the river's behavior. The construction of Glen Canyon Dam upstream in the 1960s dramatically altered sediment flow through the Grand Canyon. Vast amounts of sand that once replenished beaches and riverbanks are now trapped behind the dam. As a result, the river has become clearer but less dynamic, affecting habitats for fish, plants, and wildlife. Many native species that evolved with seasonal floods and shifting sediments have declined. In response, scientists have experimented with controlled releases from the dam to mimic natural floods, redistributing sand and rebuilding beaches. These efforts highlight the delicate balance between human infrastructure and natural systems, showing how modern decisions continue to shape even the most ancient landscapes. Long before modern dams existed, nature created its own barriers. Volcanic eruptions in the western Grand Canyon sent massive lava flows into the canyon, where they cooled and hardened into towering natural dams. Some of these structures completely blocked the river, forming enormous temporary lakes that stretched far upstream. Geological evidence suggests that certain lava dams reached heights of hundreds of meters. Eventually, the river overtopped or eroded these barriers, unleashing catastrophic floods that reshaped the canyon floor. Remnants of basalt and gravel deposits still mark these dramatic events. For geologists, the story of lava dams reveals how fire and water together sculpted the canyon, leaving behind landscapes forged by violent and extraordinary encounters. The Colorado River also supports life found nowhere else on Earth. Its waters are home to endemic fish species, such as the humpback chub and the razorback sucker, both uniquely adapted to the river's once turbulent conditions. These fish evolved in an environment far different from today's regulated flows, making them especially vulnerable to habitat changes. Conservation programs in the Grand Canyon now focus on protecting these rare species. Through careful monitoring, habitat restoration, and controlled flooding, the distinctive curved back of the humpback chub has become a symbol of this effort. Their survival in remote tributaries serves as a reminder that the river is not only a sculptor of stone, but also a cradle for irreplaceable life. Despite its ancient appearance, the Grand Canyon is not static. Seasonal floods driven by snowmelt and heavy rains continue to reshape its features. When the Colorado River swells, it erodes banks, shifts boulders, and alters channels, subtly and sometimes dramatically changing the landscape. Traces of past floods are recorded in terraces and sediment layers along the river's course. For ecosystems, floods are both destructive and renewing, clearing old vegetation while depositing fresh nutrients. Although dams have reduced the frequency of natural floods, occasional controlled releases attempt to replicate their effects. These forces remind us that the canyon is alive, continually reshaped by moving water. Sandbars and beaches appear and disappear with each season. Fine sediments carried by the river settle in eddies, coves, and side channels, forming temporary landforms that are constantly rebuilt and erased. For rafters, these sandbars provide essential campsites. For scientists, they offer insight into how sediment transport responds to changing flow conditions. Before the construction of upstream dams, natural floods regularly refreshed these beaches. Many have since diminished, but experimental flood releases from Glen Canyon Dam have shown that sandbars can be restored, improving habitats for wildlife, and creating safer spaces for recreation. This ongoing cycle illustrates a fundamental truth. Rivers are systems in perpetual motion, shaped by balance, disturbance, and renewal. In the Grand Canyon, even features as small as sandbars and beaches reveal that the landscape is part of a living system shaped year after year by water and sediment. Along the course of the Colorado River, flowing water has not only carved the canyon itself, but has also sculpted countless caves, alcoves, and overhangs into its walls. These hidden spaces form where currents and floods exploit weaknesses in the rock, slowly hollowing out sheltered pockets along the riverbanks. Some of these caves serve as quiet refuges for wildlife, while others preserve traces of past human presence, from ancient fire pits to artifacts left behind centuries ago. Geologists study these formations to reconstruct the river's historical flow patterns, while biologists examine them as unique microhabitats. For rafters drifting downstream, stumbling upon a concealed cave can feel like entering another world, a cool, shadowed sanctuary tucked between softly glowing stone walls. Together, these spaces highlight that erosion is not only responsible for vast vistas, but also for intricate details shaped patiently over time. Each hollow tells a story of the river's steady determination, carving the canyon one small pocket at a time. Despite its ancient appearance, the exact age of the Grand Canyon remains a subject of scientific debate. Some evidence suggests that the modern canyon began forming around 6 million years ago when the Colorado River established its current course. Other research points to a much deeper history, proposing that parts of the canyon originated tens of millions of years earlier, shaped by ancient rivers long before the present landscape existed. Techniques such as thermochronology, which measures how rocks cool as they approach the surface, reveal that certain sections may be far older than others. The prevailing view today suggests that the canyon developed in stages as the Colorado River connected older valleys and deepened them into a continuous gorge. This ongoing debate reminds us that even the world's most iconic landscapes still hold unanswered questions, shaped not by a single event, but by complex processes unfolding over immense spans of time. The Grand Canyon also functions as a natural laboratory for studying climate change. Its immense vertical range and detailed geological record preserve evidence of past environments, from ancient deserts to shallow seas. These layers offer scientists a window into how Earth's atmosphere and ecosystems have shifted over hundreds of millions of years. Modern climate variation is visible within the canyon as well. Over a relatively short distance, hikers can move from cool, forested conditions near the rim to intense desert heat near the river below. Researchers use these gradients to study how ecosystems respond to differences in temperature and rainfall,